Hello everybody, what is up? Another day of CS202, video 3. We got Thursday, last day of week 1 actually. Believe it or not, we've actually covered quite a bit of material considering what you would have covered in the regular semester. And today we're going to do quite a bit more. So hope everybody's doing good today. So today we are going to be covering inheritance and composition. And those are going to be very, very important topics that have a lot to discuss. But another term, by the way, for composition is aggregation. However, before we go into the topic of today, we do have to finish coding our little UML diagram that I showed you last time. And what we'll do actually is we are going to be using this example that we've created, and then we're going to improve it using inheritance and composition, and we're going to extend it to do more than this. So we will definitely build up on this. So let's go ahead and start up with that. Then how many people we got? This thing shows me like delayed. Why doesn't it show me the top of the screen? It's like cut off. Let me refresh the page. Oh, it's like a glitch that's happening on Chrome. I can't see the viewership number for some reason. It is like glitched out. That's weird. Okay, so hopefully there's people watching. But anyways, let's go ahead and go in. So here I went ahead and created a basic file, just include IOStream, you know, basically a hello world kind of program, just so that we don't have to spend the time doing that. And we're going to jump right into actually coding what we have. So I don't know if there's an easy way that I could like impromptu throw in the code on the side here so you could see it both. I can switch back and forth. I have to actually, I could try. Give me 1 second. I can try. So let me duplicate this. So I just have to share that. And then what I can try and do is, oh wait, no, wrong one, actually, remove that. Is I can actually do this and then duplicate this, share, and then I can add this input source here. Display capture, I think it was display capture. No, it wasn't display capture. Which one is it? I didn't think about doing this beforehand because I didn't think about it at all, but this could work. Let me just copy this and paste it here. Paste reference, paste duplicate, paste duplicate. Okay, and then now I can do this. And then you can see both the iPad and the screen. Technology, huh? You're gonna see that weird black bar there. You know, that's not the ideal, but actually what I can do is I can do this. Yeah, this will work. And then let me move it actually there. Yeah, okay. So that will do it. I'll call it coding in iPad, and yeah. Okay. So can you see both? You can see the iPad and the code. So now what we're going to do is we're going to be coding that right there into the code over there, okay? And I can kind of manipulate it here. So let's refresh our minds just in case that you don't remember what we were doing. So what we were doing was essentially we created this UML, which a UML is a way to represent our class, or as a sort of the blueprint of what we want to code before we even code it. Is the universal modeling language. And we're creating a ship, a Star Wars ship, but it actually could be any kind of ship. And our ship has a couple of attributes, and operations that happen to it. And the attributes are going to be the kind of data that is associated to each object or instance of a ship. And those kind of instances can be things like a TIE Fighter or a Millennium Falcon or X-Wing and these other things. And the attributes that they all share in common are they all have a health, they all have a ID to them, which is unique, by the way. Well, so, well, they're all unique variables, but what I'm saying is there can't be two ships with the same ship ID number. Then we also have a maximum speed. They have an array of weapons, and what does MAN stand for? Maneuverability, and so on. Okay, and then they also have some functionality, such as getting the ID, because that's a private variable. We know it's a private variable because it has a minus in front of it, and it returns an integer, as you can see. Although technically, I guess that should return an unsigned integer, because that would match this. Yeah, so we should probably switch that to an unsigned integer for the get ID. So here, we can do that. So there we go. And then there's a takeoff, a land, and a take damage. A take damage is actually going to lower the HP of the ship, so that's interactive, okay? And we also have a destroy. We have a gap in that. I have no idea why. I guess we never added. So I'm going to remove that gap so I can compress this so it fits better for your viewing pleasure. Oh, it's moving on its own, man. That's weird. Okay, interesting. I think it's interacting with my clock. What happens if you choose any instead of unsigned integer? Well, first of all, let's make sure you understand what an unsigned integer is. An unsigned integer is one that can only be positive, and it does that by using all the bits to count those positive numbers. And so, if you try to store an integer in an unsigned integer, and the integer happens to be a negative number, it's going to be stored as a really big positive number potentially. That's one scenario. Other scenario is if you try to store an unsigned integer into an integer, and the unsigned integer is bigger than 2.1 billion, what's going to end up happening is it's going to end up resulting as a negative. So really, that's the only difference. That, you know, all the 32 bits that are used for the integer, 31 of them are actually for the number, and 1 bit is for the sign, whether it's positive or negative. And that's for a regular integer. For an unsigned integer, there's no unsigned, so there's no sign bit. That's why it's called unsigned. And it's using all 32 bits. And this is usually a 0 in both scenarios for numbers that are anywhere from 0 to like 2.1 billion. But when you get beyond that, you would run out of space in this scenario here. Whereas here, you could actually switch this to a 1, and now you can go from 2.1 billion up to about 4.2 billion, which should be about twice that size. I don't remember the numbers exactly. So that's kind of the difference between them, okay? So, yes. Okay. All right, so let's go ahead and put this like that. Okay, so then we can see it. And you guys can see that. Tell me if it's not readable or something. There we go. Okay, so moving on over here, we are going to start by calling in this a class and the name of the class, which is the one in the box there. So that's ship type, and then we put a semicolon at the end because it's a class. And we're gonna go ahead and list all variables first, then all functions. And we're gonna kind of go with that technique of first listing all the public variables first. Although technically, if we listed all the private variables first, we would save one line of code because we could just list private variables like saying unsigned int ID, because, you know, by default this is private. But I kind of want to mimic exactly what we have, so then we will go ahead and put the keyword private like that, and we will put the unsigned int there like that. We also have a static variable. That's the one that you just like right there, and that is called unsigned int static. Actually, it's called count. Remember, static can actually go here, Or where I prefer, and I think it makes more sense, is here. Okay, I don't know why they let you do it in both places, but it's just a thing in the compiler. The parser, I guess, is cool with either one. So yeah, that's the private variables. The public variables, we have max speed, which is a double. We have weapons, which is an array. If we were doing this with dynamic memory allocation, we would be able to just make this a pointer. For now, I'm actually going to, I could make it a fixed size array, or I could make it a vector. Let's go with a fixed size array. We haven't actually used one in the class. So string weapon 5, just say 5, okay? Then we got, actually that's too many weapons, 2 weapons. Then we got our maneuverability, which I'm just putting man. Maybe maneuver. Then we got our acceleration. Then we got, and the reason why I'm not using the exact same thing is because remember when I was writing this, I abbreviated it because I didn't want to have to write too long because we were getting short on time. But you know, usually the names you pick at this point of the UML are the exact same names you want to use in the code. Like that, you want to do the same. In our case, I didn't because I was rushing through it. But ideally, you want to pick the names at this point because why not? You can pre-plan ahead of time things with variable names that way. But yeah, so then we got another one which is capacity. Oh, and HP. Well, we have a private one actually, so that goes here. Health points, but that one HP is a pretty popular name, so I'll leave it like HP. Okay, so we got all our variable names. Moving on to our functions. We are going to go ahead and make our functions, all of them beneath. So, although frankly, you know, this is an interesting thing. Even though in the UML your functions go beneath, I typically see, like in all my time that I've seen code, I always see people write the functions first and then the variables and classes. Like it's actually kind of weird to put them variables and then class and then functions. So I'm going to stick with what I'm familiar with. But either one is perfectly fine. Public. Private, like that. Okay, and now we're gonna start with the first function, which is getID. It returns an unsigned integer, getID. We're gonna put all the class declarations outside. That way we can make our class nice and compact. Takeoff. In fact, why don't we put the you could even put them in a separate file, you know, so you can see multi-file compilation. We can include the file, but no, because then I gotta switch back and forth between files, and that might be a pain to show examples. But you know, that is definitely a possibility that we could do. In fact, that's a very common thing to do, is to separate and put the blueprint of the class here, the class declaration here, and then put the definition of all the functions in a separate file, which is your implementation file. So this would be like the header file, per se. Anyways, put the rest of these, land, and then take damage. Void take damage int. We're gonna be super efficient and pass it as a const int like that. Okay, that means that we're passing it by reference, but by putting const in front of it, it means that it's a read-only variable, so we don't accidentally try to modify that. On the private side, we have a function called destroy, and that is void. So as you can see, things translate pretty one-to-one between our UML and the code itself, okay? All right, what remains now is to go ahead and actually implement these functions. Now, this is something that is not in the UML. This is not in the UML at all, and this is something that you have to do. That's okay, because again, the idea of data abstraction is that maybe one person is assigning the class, and then these implementations get assigned to different people to go ahead and actually do, you know, and that's okay, because the person that's doing destroy doesn't need to communicate with the person potentially doing land. Although technically, the person doing take damage may want to use the destroy function actually to destroy a ship if after taking damage it goes to 0. However, he knows that he can just call the function destroy and the ship will get destroyed. He doesn't need to worry about how destroy is implemented. He just knows that he can call it. Even if it hasn't even been implemented yet, he can already use it in code. And once it gets implemented, they can actually test the code. So yeah, let's go ahead and define our functions here. So the class is called ship type. So in front of all the function names, we need to put in ship type and our scope resolution operator. So I'm just going to copy and paste it in front of all of them. And also the other thing that we need to do that's not in the UML is initialize the variables, because we want to ideally initialize the variables to something. That is the best thing to do. And that is not, there's nothing in the UML that discusses how we're going to be initializing the variables. Scroll down. Okay, and so how are we going to do that? Well, we have to decide what are some good default settings for these variables, and where are we going to put that? We're going to put that in a constructor. So we are going to make a constructor, a default constructor, but also with variable parameters. That way, they can either call it with nothing, or what is more typical. Typically, when you do a constructor, you want to have a hard-coded sort of default, or also you want to have one constructor that can have all parameters for all variables to initialize them custom-like. As for your question of whether it's UML used in the industry or school thing, I think it's a bit of both. Companies are going to have their own sort of pipelines of work and how they plan code from like planning phase to implementation phase. But if they don't, let's put it this way. If they don't use UML the same way that we're doing it here, they're going to have an equivalent thing. They're going to have their own sort of UML that describes these kinds of things, you know? So they might have something called cookie ML, you know, for some reason. And then essentially they're going to have some similar sort of descriptive things like the name of the function, the type, and those kinds of things, depending on the language that you're working on, okay? So they may not be using UML as UML is. Like, although UML is supposed to be a standard, it's like USB, you know? That's the whole idea between UML. It's kind of supposed to, whoa, everything got minimized. Oh, snap. Hold on a second. There we go. So, did I maximize everything? Come on. Let's see what else. What needs to be? Oh, Discord needs to be maximized. The chat needs to be maximized. I think I accidentally did the little bottom icon thing on Windows that minimizes everything. So, yes. There we go. Okay. Also, my canvas would just randomly appear. Fortunately, the password is sitting there. Otherwise, that would be a terrible security leak. So, yeah. Okay. Okay, so what are we going to initialize these to? Well, first of all, let's continue making our constructor. We are going to have a parameter for everything, but we're going to set them with defaults. Okay? So we need to have a double in the parameter. And ideally, maybe we want to make all these conts, but that's a lot of typing, so I'm going to skip that much. Let's say that we might also want to initialize an integer, an integer, an integer, an integer, and then 2 strings for the weapons. The order doesn't have to be the same as the variables, although that might be a good idea. So I guess but I kind of stuck with the types as well as an ordering. So this is something you want to put in your documentation so that people know which parameter is for what. So yeah, that'll be good enough. Okay, so let's go ahead and actually throw that in. Okay, so if you wanted to do good documentation, what you would do is you would say something like parameter 1 is going to initialize max speed. By default, it will be, you know, 0 or actually 100. Okay, something like that. And you would do that for all parameters. That way, when you are calling the function, if you're calling the constructor here. So if I'm doing ship type TIE fighter underscore, you know, it will tell me the documentation. It should autocomplete the documentation. If the code was parsed correctly, I've had probably typos in the code that's not letting it do it. Here, let's see what errors we get when we try to compile. Well, first of all, I'm missing all the parameters here, all the variable names for the parameters. So we'll just call them m max man acceleration capacity HP. Actually, HP we're gonna always set to no, because ships might have more HP. So yeah. String W1 and W2. Okay, that's just W2. It's kind of hidden by the UML. Actually, we don't really need the UML anymore, do we? I think we're okay on that, so we can hide that. So now let me try to compile and see where I have typos. I have typos on line 26. Double max, int man, int ace, int cap, int HP, string 1, string 2. Yeah, I can see I have a typo somewhere here, but I don't actually see the typo. Oh, well, yeah, I'm missing the class name. Okay, there we go. And then line 49. Ship TIE fighter. Oh, yeah. Well, anyways, now this should tell me the parameters. Like it should autocomplete this thing. Let's try it. Ship type TIE fighter. There we go, like that. Okay, so as I'm putting in the parameters, it will pop up and tell me like these are the types that each one takes. You can see the variable names there, and you can see the comment that I had. Parameter 1 is going to initialize max speed. By default, it will be 100. You see that? That's why documentation is important, because then this can be seen by other people coding it, and they don't have to remember what order you put the variables on. Because you might have, like here I have a bunch of integers. And hopefully the names of the parameter of the code here helps me figure which is which. But if it doesn't, then that's okay, because you will have documentation. So it's important to do documentation, okay? So anyways, we're not yet at the declaration of this. I just wanted to show you that. So I don't usually put documentation in the examples I do in class, because that would take a long time. But you should always do that in your assignments when you're coding in general. So follow the rubric rules for the kind of documentation that you need to have. But anyways, so all of these though, like I said, they're gonna have a default. So max speed will be 100, maneuverability will be 100, and we'll do scale 1 to 10. And then 100.0 technically. Acceleration will be also 10. Capacity will be a default of 1. HP will be a default of 100. And string 1 will be a default of lasers. And weapon 2 will be proton, or none. How about this? None. There is no default second weapon. And I think, yeah, we'll do like that. Are they called lasers? Well, they're called phasers in Star Trek, but what are they in Star Wars? Fire, incoming, blasters, I think it's called, blasters. I don't know, for big ships they're called blasters. Yeah, okay, cool, blasters then. Because they're like, intensified forward batteries. I don't want anything to get through. So they use the word battery there. But yeah, that was for the Star Destroyer. Okay, so cool. Okay, so now we these values here that we have in this big line. By the way, because C++ is white space insensitive, you can do this. This is perfectly fine without the Q, because it will just ignore the line feed as it's progressing in this. Okay, just don't do it in the middle of a variable. Now that will cause problem. But if you do it in between where you have normally a space, you can do this, and that's how you can keep your K and R like under 70 characters wide, sort of since for formalities for the assignments. So now we are going to initialize the variables. Now, frankly, I am compelled to use this like this, max speed equals max, because we're already kind of wide. But remember, the other way that you can do this, and the way that I will do it, because I do want to remind you about this way, is, and I'm doing it in a different line, but you could do it in the same line, is you can do it like these, max speed, and then put in max like that. That is fine. That actually works fine. And it's actually better to do it that way. So we'll do it like that. Maneuverability gets the variable man. Acceleration gets the variable ax. Capacity gets cap. HP gets, shoot, we got 2 HP variables in it. Oh, I think that'll be okay. Yeah, I think that should be okay with the naming convention. We'll see if it compiles. And then for the that's a good question. I don't think I ever tried doing this initialization into indexes in our variables. This should in theory work, but I don't think I've actually ever really tried it. So this will be a good experiment. Let's put this in the next line. I think I would do it like this. But I'm not 100% sure actually, because I mean, I've never really, you don't usually use fixed size array. So the first thing you would do, if you would actually dynamically allocate this array, and then you would actually do this, or if it was a vector, you'd be doing pushback. So that's why I've never run into a situation where I've done this before. So this will be a learning experience. And technically, actually, at this point, there's nothing to write inside the body, unless you want to say something like cout, and you can leave it empty, but I'm going to say cout. And this should be spaced out this way. So I guess we'll space these out further to not confuse people reading the code. We'll say new ship created. We do need to do some things actually to this. We need to assign the ID. That's the one that we didn't initialize, right? Is there anything else? Max speed weapons, yeah, ID. So here's how we're gonna do the ID. We first need to initialize the ID to 0. And by the way, I think, I'm not 100% sure on this. If you don't initialize static variables, normally with any variable, if you don't initialize it, there is a percentage of probability that there's garbage in it, which is really bad, which is why we always preach to initialize variables. However, I think, and I'm not sure, that C++ will always initialize statics to 0, even if you don't. I think, but I'm not 100% sure. I still think you should initialize them, but I think that's the case. Okay? I'll ask Ben, who probably knows. He's the guy who does 326. He probably knows for sure if it actually does happen to be initialized to a 0 always or not. So yeah. What am I doing here? Oh, sorry, I was talking and typing at the same time. So max speed max means max speed equals max. Yes. Max speed equals max. Yes, the first one, not the second one. Because remember, max is just a parameter that we're passing in. Max speed is the class variable that we're trying to actually update. So it would be bad if it meant the other way around. We wanted this to mean that max speed is getting the value of max in it. Like max speed is getting the value of max. It'd be pointless to set this max, because this is just a parameter in the function that we're just using to feed data into our class when we were building it for the first time. So yes, the first one. Okay. So now we're going to initialize the ID to be whatever count has, and then we're going to increase count. Now we're going to do it with the plus post increment, because we want our ID system to start from 0. And so the first ship will have 0, but the count will be 1 afterwards, because ID will get the current value of count, but then count will go up. So after we create one ship, the first ship will have ID 0, but our count will be 1, which is correct because we have one ship and it has an ID of 0. If you wanted it to be the other way around, where you wanted the IDs to start from 1, then you would do pre-increment. And in that case, the first ship would have an ID of 1, and your count would also be at 1. So it depends if you want your counting to start from 0 or 1. C++, everything starts from 0, and most languages things start from 0. So even our custom counting systems should start from 0, because it'll make our lives easier to just be consistent in that manner. But it's free country, you can do whatever you want. So yeah, that's why I'm doing it like that. And I think that's it. I think we got everything in there. Another thing I'm a little questionable is about the static thing. But we'll see. So let's see what we have here. It's private. Okay, so I do need to put the word static here. I forgot. I did it yesterday and I already forgot. What did we do yesterday on this? So you do put the data type. Okay, that's what it is. All right. Unsigned things. There we go. And that's why your test is open notes. So there you go. Okay. So error, expected parentheses before that. Okay, so this is the experiment that we were doing to see if this actually would work. So it doesn't seem to like this system using the square brackets. Okay. Let me try something just out of curiosity if that would work. Technically, for weapons, that's the first element of the array. So see what happens if you do it like that. Invalid initializer expected at the global scope. Okay, but then, so this one I don't know. I could try to do pointer arithmetic and see if maybe that could. I don't think that would work. Nah, that won't work. Okay, that's fine. So, like I said, I had never tested it before, so I was actually curious if it would work or not, but it doesn't seem to work. That's okay. The way we can do that is we can just throw it in here. We can do weapon 0 equals W1, weapon 1 equals W2. And that will take care of doing it, you know, that will work. Okay, so now if we run it, nothing really is gonna happen because we don't really have anything in there. But before we continue, let's go ahead and implement these. Actually, if I was coding this like as an assignment, I would actually, before I implement the functions, I would just test to see creating an object and seeing what happens. I can do that by just go ahead and doing ship type and then TIE Fighter. First, like that, let's see if my default works. New ship created, okay. I don't have a print function. That would have been something good to add to this so that we can see all the stats. That means we did some poor design choices when we did our UML, so we might have to update our UML for that. Maybe that's why I left that space. I'm just gonna say that's why I left that space that I had and I removed, because we were thinking about that, but then I forgot. Even though it's not true. We're gonna call it a print, or how about just stats? No, print stats. That's a nicer name. No, stats. It's less typing. Stats, void. Okay, so there we go. So now we can go in here and create such a function. It's a public function because we want people to be able to call it. So that is going to be basically an accessor function per se. So void stat, is it stats? Yeah, stats. Like that. Okay, and let's actually go ahead and code that function first. This is something that I personally like to do when you're dealing with classes, is to have some sort of print function, because that is going to help you when you're debugging, because you would be able to see if like your variables are set to the right values at any time. So like let's say we're testing the take damage function. It would be nice to print before the damage, call that take damage, and then print again, because then we will see if the HP goes down. So that print stats is going to be very, very, very useful to just kind of watch things happening and see and make sure that we don't have any bugs. So because of that, it's very useful to have that kind of function in it, just even for debugging purposes. So okay, let's go ahead and do that. That's gonna be a painful one to write because it's a lot of things in it. So I'll just go ahead and write it. So we don't have a name for the ship. That's something else that we probably wanted. There's so many things we wanted, but again, you know, I don't want to spend 2 days writing this, so we'll leave it as it is. We'll just print ship details. And then, okay. So the first thing that we have here, I'm gonna pull the UML for that. That actually will help me out, because I can see what we're printing in. You're missing a P in ship type on line 39. Oh yeah, thank you. Good catch. All right, so ship details. So we got max speed. So we're gonna say max speed, and then we're gonna put in colon our max speed variable. Then we've got, what is next? Weapons. Weapon 1, and then we'll say weapon 0, and then actually I need a line feed here so that it goes to display, and then we just copy paste that into the next line, weapon 2, and then I am gonna put acceleration. We're gonna go ax. Why not? And then acceleration. And then the same line, we're also gonna put maneuverability. Okay. Then we need capacity. And then here, now it'll fit here. HP, and then finally the ID. Actually, I think the ID should go on the top. So instead of the word details, or actually this might be a good spot to print the ID out. Yeah, like that. I think that'll look okay. Well, let's test it and see. Okay, so we got all our variables in there. So let me turn that off again. And now, I also forget there was a stats with no type. Did I not call this type? Oh, I need void actually. Void. And then we are missing a semicolon on line 45 right here. Okay. Technically line 44. Oh, you know what I just saw also? We want to have to flush everything out. I don't like to flush everything out after each one because then it slows down the printing process. So that's why I was using the \n. Okay, cool. So let's actually call the print function so that we can see if this thing worked. So typefighter.stats. Again, the dot is called the member access operator. Ship 0. That's good because it's the first ship that we made. Maximum speed 100, blasters none, acceleration 10, maneuverability 10, capacity 1, HP 100. Perfect. Everything is working fine. Let's just test to make sure that our counter system is working fine. So let's try to make another ship and then see if that ship will be ID 1. So we're going to make an X-Wing now. And then let's go ahead and try printing the stats of the X-Wing. You can see that the ship is 1 instead of ship 0, so that means that our static variable is working as it should, and it's assigning an individual ID to each ship successfully. You can see that everything else is basically the same. So instead of that, now let's go ahead and try and testing our custom constructor, right? So okay, this is where we're actually going to take advantage because I can't see up there. I can't have the constructor at the same time as this in the screen. So that's okay because we're really going to take advantage of this. We just need to know the first one. What is the first one? I don't know. Let's put 5. Okay, what is the first one? Now we can see the 5. Okay, that's the max speed. So we're going to say 500, comma. The next thing that we have is acceleration. Looking at, oh no, maneuverability, which is 10 as a default. We're going to say that the X-Wing has a 9 on maneuverability. And then acceleration, it has an 8. Capacity, X-Wing is just 1 passenger, so we'll leave it like that. HP, we'll say it's 110. It's a little bit stronger than the TIE Fighter. Actually, no. Let's make this a balanced game. Let's make this 100. And then it has blasters. That's okay. So we'll do blasters again. And then for the second one, it has, what is it? Proton torpedoes? Is that what they shoot at the Death Star? When Luke blows it up? I think it's proton torpedoes. Okay. All right. So now you can see that we are able to test whether the constructor works with our print function, which is why I love doing the print functions like as the first function that I actually implement. So the ship ID system is still working, and you can see max speed got set to the right thing. Blasters and proton torpedoes work. Acceleration and maneuverability worked. Capacity worked. It seems like it worked. We're not 100% sure because we didn't try changing it. And HP also is the same situation. So there you go. So you see, this is the process of you making a class. You write your first plan ahead of time. Hopefully you don't miss out a very, very obvious printing function to debug like I did. But hey, it's okay. We added it in. Then you go ahead and develop some sort of I/O to your class so that you can see if the things are working. And by I/O, the O part of that means output. That's a print function. The I part of that is going to be the constructor, at least in this case. So now that I have this basic functionality, I can go ahead and move on down the hierarchy of my class to develop the remainder functions. So let's go ahead and start with the take damage, because that's actually let's start with the easy one. Let's do get ID. That one is pretty easy. All I gotta do is return the ID, right? And now if I want to test that function, I can just call it. I can say something like, let's actually leave the end line, that one there, and let's try to do cout ID of X-Wing is, and then I can't do this. I can't do xwing.id because it's a private variable. In fact, it doesn't even show it in my autocomplete, which is a sign that is a private variable. The reason it doesn't show it as well is because there's no point in showing you variables you can't make use of, right? It's only like it's just temptation, basically, to make mistakes. So instead, it does show you that there is a getID function. Now, if I was a good programmer, I would say returns the ID of the ship. And so that way, when you go ahead and type in X-Wing member access operator, get ID, then it did an update. Oh, I forgot to save. That's why. Hold on. Let's try it again. Dot get ID. Why is it not updating? Oh, there we go. Now it does. Okay, returns ID of the ship. So it's only, I guess, when you're putting the parameters in. But this whole system of like autocomplete is not visual code specific. Pretty much all IDEs have this sort of functionality, or it can be added in with an add-on. So it's very popular. Tons of people use it. In fact, one of the things that I don't really use, but real coders like do every day is there's so many keyboard shortcuts to autocomplete and copy paste and do all these things that you just practice with time, and that's what makes you code faster. But before you get there, you gotta learn the basics. So I don't like using shortcuts in the video because then you guys will be like, whoa, why is code appearing out of nowhere? Actually, you'd be surprised. Sometimes when you're teaching people that have never used a computer before and you show them like Control-C, Control-V, they're like, oh my gosh, like how did you make code appear out of nowhere like that? And I'm like, wow, okay, this will be a fun semester. So yeah, hopefully you all know Control-C and Control-V, right? So yeah, block indentation and comment in and out are my favorites so far. I don't like when people do this kind of coding like that. That bothers me a little bit. It kind of triggers me. So yeah, yes, kappa. Okay. So anyways, okay, so getID worked, right? We tested that. I don't think we actually ended up testing it because we get distracted. Yeah, ID of X-Wing is 1. Yep, it works fine. It's just we forgot a line through there, but whatever. So that one is working fine. I'm gonna go actually get rid of it because we don't need to use it. At the curly bracket at the end of the function. Yeah, this is much better system. Now, the other thing that triggers me though, okay, I respect when people do this because I do it. If A is greater than B, but big but, I like to do this like this, and then you code here. Happy. This is okay for me. What I get triggered, and it's perfectly fine, but I don't like it, is when people do this. And now I'm triggered. I don't know why this bothers me when people do that. Like, I'm like, and you know, it's perfectly okay. Like, tons of people use it, and it saves you a line of code. But for me, it just feels wrong, like deep in the heart. You know, it just seems wrong. So I guess it's a little bit of a hypocrite on my side that I make fun of people that do this, but then I get triggered at this method. You know, so yes, but I don't know. I know a lot of people say, you know, it's okay, but like I said, and yes, there are standards like NR, and then they say that yes, you know, you should do this like this, but I personally don't like it. So in my skeleton codes, you will never see this unless I actually did it by accident. I don't know why. It just seems to me like I like my if and else to line up. I think that's what it is. I like them to be on the same indentation. I'm a very indentation heavy person. You know, I really also get triggered when people don't indent their code. You know, like I guess, I mean, I've been coding in Python for a while. Kind of makes you indent things, otherwise the code doesn't compile or doesn't interpret, I suppose. So yes, that I've kind of indoctrinated myself into doing. But yeah, those curly brackets are weird. Okay, anyways, moving on. Okay, so let's do take damage, because that's the only actually interesting function in here. But first, let's do the, actually, well, it doesn't matter which one we do first. So yeah, let's just do take damage. Yeah, first. So take damage is just going to be the parameter here that you do. So all you're going to do for that is you're going to take your current HP, and you're going to subtract from that the, I guess you can do minus equals technically here. Equal minus or minus equal? Yeah, minus equal. Okay, and then whatever damage is. So basically, whatever the damage is taken, it will be subtracted from that. So let's go ahead and test to make sure that this works. Let's call our print function, our x-wing function before and after. And in between, let's go ahead and say that the x-wing takes damage of 25. Okay? And then let's see if that will actually go to make our health go down from 100 to 75. Yeah, there we go. Perfect. Cool. So that works fine. The problem is, suppose that they shoot us with something that does over 100 damage. You know, like a headshot multiplier, except in the ship, you know, whatever that is. That's bad. Negative health. Okay, that is going to cause some problems in our game. So we want to destroy the ship once it reaches to 0. So what we want to do is we want to say something. Well, there's a lot of ways that we can do this. We can either set the HP first and then check it, or better yet, I would actually check it before doing it. So I would say if HP minus damage is less than or equal to 0, then go ahead and call destroy. Okay, and then set HP to 0. Actually, that probably could happen in destroy, setting the HP to 0. So I don't know. Let's say I don't trust that it's being done in destroy, so I could put it here as well. What I don't want to do is probably modify the HP after destroy, because if this is some program where there's dynamic memory, I may not even have an HP left over after I destroy the ship. So if I'm gonna try to mess around with the HP and not trust that destroy does that, then I can do it before, but don't do it after. Okay, and then the other case is the else clause of this. Again, you can see how I'm doing my else. So yeah, that works fine. I could have put a return here and then not have the else clause in here, but I don't. Again, returns are like breaks. I want to avoid them unless you have to. So okay, so if I run the code now, at least now I will have a 0 instead of a negative. But I actually haven't done destroyed. So what is destroy? I don't know what we want to do with destroy. We don't really have a sign here to keep track of whether something is destroyed or not. Frankly, we can use the HP for that. But let's just say we do a sound effect. You know, we can say kaboom. And so now we should basically just see a kaboom happen. Where? Anybody see it? There we go. Kaboom. Okay. So there you go. That is going to be basically your ship being destroyed. Now, maybe that's a placeholder. Maybe the developer destroy actually has to do some like super complicated thing to call like an animation and a special effect to the game or whatever, that's okay. He can take care of that. For now, that's good enough for our purposes here. So yeah, and in addition to that, maybe we want to, maybe this is the function that actually ensures that HP gets set to 0, you know. So yes, that could be repetitive, but who knows, that this guy and this guy might not be on talking terms when they're developing this. So that way, you know, they both set it to 0 to be safe. So from there, we have the land and takeoff. Let's say that, is there anything that we gotta change from this? Max speed, weapon, acceleration, capacity. Not really. So we can just say ship took off. You know, this may be saving to a console or something. And then ship has landed. Not the most exciting game so far, but that's okay. Don't worry, you'll do Battle Royale probably, and then you'll get excited. Okay, so yeah, we can test those the same way if we wanted. We can actually say that it can. We could actually enrich it and say if HV is 0, it can't take off or something, but we're not gonna do any of that. Let's just say the TIE Fighter dot land, you know, just to test that, and then TIE Fighter dot take off. I don't know why the autocomplete. Oh, I see, because I put a dot. I see that. Also, it makes more sense to actually take off and then land, unless you are spawning in the air. So ship took off, ship has landed. Okay. So there you go. We're done. That took 51 minutes potentially to code. Longer than I actually thought it would take. But now you have a very good example of doing classes. And when you're doing assignments 2 and 3, you can refer to this to how to develop that. But now we're going to take it a step further and go into today's material. So today's material is and is there any questions, by the way, about that class that we made? Let me know. But otherwise, today's material is inheritance and composition. So suppose that now I want to expand the code that I just made, you know, because like our game was so successful that we want to make some DLC, okay? And DLC is all great and good, right? We want to make some money. So our DLC is going to release, if we were just to release more ships, then we would have to kind of be limited to the same sort of functionality of the ships, right? That they have this. But our DLC is going to introduce a new feature that our ships can have. And what is that going to be? That's a very good question. Does anybody have any suggestions on what our DLC could have to sell more of the same thing, essentially? Our ships could maybe have a skins. Okay. No, skins. We can do the skins. And barrel roll. Yeah, let's do skins and barrel rolls. All right? Let's just say we have skins. So right now, there is no variable to define the skin. But we're going to introduce in the DLC a skin variable, because then we can associate a skin so it gets loaded into the game. That's perfect. I mean, that is actually the DLC. So yeah. Okay, so here's the thing. One of the ways that we could do this, I suppose, is we could go in and edit the code. But that might break other code that we currently have. So what we're going to do is we're going to make a completely different class that has the same code as this one, but with the added feature of also having skins. So the naive way to do it would be to go ahead, and actually I'm going to, because I want to leave this for you guys when I make it available, I'm going to actually start, I'm just going to copy and paste this into a new file, so that since we're going to play with it, you can have the OG version still. So we're going to call this ship DLC, the quest for more money or something. Okay? So that way, you have the original before we start messing with it. So cool. Okay. And it compiles. So, all right. So as our DLC, what we're going to do to be able to achieve that is we basically need to copy this whole class and make another class, the exact same, except this one is going to have a string called skins. Okay? And then because they have a string called skins, we are going to have to add it to our constructor potentially, you know, here. And then we need to add it as well over here to the, where's the constructor? Where does it end here? Right here. So string sk is going to be comma skins sk, and by default we're gonna say none because we want our users to buy the skins, so we don't want to give them free skins. And then from there, of course, we want basically to showcase this with some fancy functions like show off my skin kind of thing. That sounds explicit actually. I don't know. Show off skin, not my skin. There we go. Okay, there we go. And so now we can have a void show off skin, and we can say cout this user is using delete skin, and then we print out the skin name, and then remember skins equals skills. I think that's the quote. Or skin gives me wins, something like that, right? Okay, so there we go. We have that, and then I think everything else is okay. Oh, we got a modifier print function as well to show. Yeah, they give you at least 50% more wins. So let's go ahead and put that in there as well. So we'll call a function called void skin facts. Also, we are gonna really make some money by accidentally releasing skins that have features like extra health or harder to see by the enemy. Because even though we want to claim that our skins are only for cosmetic purposes, in reality, what we're trying to do is give the user some advantage by having a pay-to-win thing, at least temporarily. Because once they bought the skin, eventually we're going to be like, oh, I'm sorry, that was an accident, and then we'll balance the game. But we'll do it again with the next release of skins, because everybody knows that's actually what happens, right? But nobody tells you. But yes, after all, we are in the business of making money, right? So yes, that is what we'll do. Auto compiles, you know. And then, you know, we can even call it and see, or we can set the TIE Fighter skin because it's public. So we'll set it to Asimov skin. TIE Fighter skin. So TIE Fighter skin. Is that what it's just called? Is it a variable called skin or skins? I guess, I don't know. Let's just test it by saying TIE Fighter dot show off skin. And also TIE Fighter dot, what was the other? Skin facts, right? Yes. All right. And bam. Let's see where this is at. Did it work at all? Oh, no. Because here's the thing. We made a new class. Oh gosh, what does this compile? Oh no, this is horrifying. Okay, well, this is one of the problems of doing this, I suppose. But here's the thing. We have two classes with the exact same name, and I have no idea why this does not even give me an... Oh, I see why it's not giving me an error, because I'm still compiling the older file. So now it's going to give me like a billion errors, because I have two classes with the same name. So we're going to call this ship type 2. So we got to go in here and modify all the names that say ship type, and call it ship type 2, okay? Like that. And then ship type 2 here, ship type 2 here, ship type 2, ship type 2, ship type 2, to be or not to be, that is the question. Okay, we still probably got more of them. Oh, it's probably, no, we made them all 2s. Although the X-Wing can stay as a ship type 1. Let's see what else we missed here. Ship type 2. Oh, probably the constructor. Yeah, right here. Okay. Skins was not declared in this scope. So what was it then? That's a lie. Did we accidentally put the other function inside of this, the top one? Here, let's just look at the actual line of where this is. Line 113. Okay, so 113. Oh, here, yeah. So ship type 2. Did we actually write the name of the function inside the class too? Yeah, we did. Okay. Okay, so let me see if I can see what's up. Line 122. Oh, we never added. I was going to add here. Skins like that. Okay, I think we just got just about everything in here. And I'm doing this whole thing just to prove a point, actually. So, but you know, hopefully you guys get the point once I do this. Okay, there we go. So now this works. This actually works. We said this user is using the skin Asimov, you know, skins equal skills, skins give you at least 1% more wins, and so on. Okay, so this works just fine. But now, you know, because we were so busy implementing DLC, we actually found out that there's a bug in the code because we got reports from users. There's an exploit in the acceleration, you know, or something. They can slow down super quickly, that it like flips the acceleration to a negative value. I don't know. There's a bug. So the point is that the way to fix this bug is we actually have to I don't know. Actually, let's just say the bug is with the ID system. So we want to start the count from 1. You know, that would be the way to fix the ID bug system. Or perhaps it was at 1 and we're supposed to set it to 0. Okay. So here's the thing. If we copied and pasted the code, whatever bugs will get detected with the ship type are also going to be available in ship type 2. There's going to be essentially a bug in both of those, right? And you're going to have to, whatever code you got to fix in one of them, you got to fix in the other one, okay? Now suppose that you have 10 different ship types, okay? They're all basically the same thing and you copied and pasted. That is going to be a pain, you know, a big headache to fix them all, okay? So isn't there a way that you could connect them so that you can only sort of extend some classes to add more features, but instead of copying and pasting, have everything that is shared the same refer back to sort of the original class? And the answer is yes. You can do what is known as inheritance. So that is going to be the solution to our problem so that we can keep introducing DLC but not have to fix the code so many times. So normally you create a class, right? And we did. We called it ship type. But now we want to make it more cooler and upgraded ship type 2. And ship type 2 really is a ship type 1, you know? It's almost the exact same thing. The only difference being that it has the additional skins variable, and then they have some functions called show skins or show off skins, and then it has the other one, skin stats or something, the one that says the 50%. So it has added functionalities and added variables. Okay, so that's what we want to do. But we want the rest of the code, so everything else, to be the exact same. And not just to be the exact same, but to be interconnected. So if I go in here and I modify something here, it will automatically modify that version as well, right? And that's what you can achieve with inheritance. Inheritance allows you to inherit all of the properties of a parent class in a child class, okay? So basically, it's a little bit misleading when you really understand what inheritance is to think about an inheritance, because when you're saying inheritance, you usually assume that the parent died and you're inheriting to the living kids. That's not necessarily the case in C++. The parent can still be alive, but inherit. So it's more of like sharing your traits because you inherited them when you were born. So like, let's say your dad has green eyes, and then you're born and you inherit the green eyes in the sense that you have green eyes. That doesn't mean you took your dad's green eyes. It just means that you have basically a copy. But more than just a copy, and this is kind of where it deviates from humanity, you have a reference to them, which means that if somehow your dad's eyes like randomly turn brown, then your eyes will turn brown at the same time. Like you're connected in that sense, okay? That's how it works. And why do we want to have that connection? to avoid the problem that I just showed you, that if we have a bug or we need to add some functionality to a parent class, it will automatically add the same functionality to any child class, which we call derived class. So in this case, we would call the sort of the upper original OG class the parent class. And we would call the child class also the derived class. Okay, so there's a couple of names for this. The original class can be called parent. It can be called, I suppose, the super class. What other names can they be for that? A parent, super class. I think those are the only ones. For the child class, that's the one that you're making out of that one. So ship type 2, it can be called child. It can be called derived. Sometimes they call it extended. Base. Yeah, that's the other term I was trying to think of. Base class. You're right. Base. So yeah, base and derived are sort of the matching ones. That's right. And then superclass. This is the, I think, subclass. Yeah, I think those are the most popular ones that you use. I personally use either parent or child, or when I remember, I suppose base and derived. So yeah, basically, that is going to allow you to save a lot of copying and pasting, because you can just, you can expand you can expand the concept of UML diagrams into a hierarchy of things. I'm trying to see examples that we did before. Okay, we did. I was thinking of a different class where we did an example of a car for the 219 class, but like, now that you understand that there's the idea of parent and derived classes, you can actually you can abstract code even further. So right now, I told you, like, your boss, he gives one guy to do a function, another guy to do another function, and things like that. But oh, yawning dog. But you can go further than that now. You can have someone make the super class that everybody else shares, and then from there, somebody else can make a derived class that focuses on the skins, on that sort of functionality. And somebody else can make a different class. So kind of switching, doing a 180 in terms of examples. When you're trying to figure out whether you should be using inheritance, there's a good sort of short term for that. It's good to remember, because there's another thing that you can do technically. So one of the things that you can do when you're making ship type 2 is you can use inheritance to make a reference. Okay, but the other thing that I can do to have all of the stuff from ship type 1 in my ship type 2 is I can make an entire new class called ship type 3, and I can actually just in my class create a variable called ship type 1 or 2. Okay, and then if I do this, I actually have all of the functionality of ship type by doing this. And then I could actually go in here and add my skin. So this is one way of doing it. The other way of doing it would be with inheritance. So which one is good for which scenario, basically? And so, oh, sorry, I typed a bunch of stuff, but you didn't see it. So here, my bad. Okay, so I created a class called ship type 3, and I merely declared a variable called ship type inside of it. And then I put a string. And so in main, if I was coding, and I was adding I was creating a ship type of ship type 3 called Millennium Falcon, I could actually go and say Millennium Falcon dot ship dot, and then refer any of the variables, like call takeoff or the functions. That's one way to do it. The other way to do it is with inheritance. And I'll explain this more in detail, but I'm going to do a quick example. How you would do this with inheritance is you type in ship type 3 inherits from ship type publicly. And then now I can go ahead and put in here string skin. And then if I was to actually create a ship type 3, although this height was supposed to be more like 4 so it doesn't conflict with the top one. In this case, I could do something like ship type 4 dot, and then I can call all the functionalities of the original one, like this, takeoff. You can see that this and this are different sort of syntax, because here it looks like it's just a regular ship type. Here I have to add this extra variable called ship. This is inheritance. This is what is known as aggregation or composition. And so when choosing which one to do is when this little sort of, I would say not an acronym, but sort of saying is useful. Okay, and we'll explore this in detail here. Composition. Okay. So when you're thinking of inheritance, which is what I'm really talking about right now, is you can think of as an is-a relationship. Or is-a, I don't know how you pronounce that. On composition on the other side, which is also really known as aggregation, depending on who you ask, that is a has a relationship. So really, that's kind of the here, I'll put actually the quotes there. That looks better. That's really what you got to think about when you're deciding whether you should inherit a class or not. If you want to do inheritance, it's because you are trying to inherit all of the attributes of a class and then sort of extend upon them. But when you're extending upon them, is what you just inherited, is a new class that you created, is it the same as the old class? So in the case of ship 2, ship 2 is a ship, basically. It's still a ship, right? The second case, which I haven't, again, talked much in detail about, is more of a situation where you want a class to have the features of another class. So I can say something like, if I have a different kind of ship that has a ship inside of it, so maybe like a Star Destroyer that also has ships inside, that actually, yeah, remember, we'll do that example. Then that is more of an aggregation situation, okay? So now switching over to a little bit of 180 with an example that I gave last time I talked to O2, which I think is good. It's important to kind of realize how you want to use your inheritance to your benefit. You know, if you're doing something like ships, okay? So I guess I'll switch it because I did animals in last time I taught this, but we'll do ships. We'll stick with ships, okay? So if you're doing ships, you know, what you want to do is, if you're going to have different types of ships, different classes of ships, you want to find all of the things that they all share in common. And then you're going to make that be your superclass, okay? So in our case, we're going to make sort of a little hierarchy. And at the top of this little tree, we're going to have the most bare possible ship, okay? So this is like the most bare ship possible. And what is that going to have? That's going to have pretty much what we have so far. Like, you know, speed, HP, and an ID system. And it might have some functionalities like takeoff and land, because all our ships can do that. But that's only because I said all our ships can do that, okay? So all of that is inside our base ship. And that's going to be sort of our super class in the hierarchy of that. From then, we can have derived classes or subclasses that can have the same functionality as this one up here, but extra stuff. So for example, you know, we have our skins. So we have our skin class, which we'll call it like, what's a better name than skin class? It would be something like cosmetic class, cosmetic ship. And that cosmetic ship class is going to basically have everything from here, but in addition to that, it's going to have the skin stuff that I showed. So show off skin, etc. This is additional data and functionality that we are basically adding on top of what is here, okay? In addition to that, we may have other derived classes from that if we wanted. So perhaps, you know, even before we add this, we might actually want to divide this into different kind of ships and add the skins later on. Yeah, let's go ahead and do that actually. So let's go ahead and create sort of in between. So maybe within ships, we have different kinds of ships. We have frigates, which are like bigger ships. We have capital ships. We have bombers. And maybe one more, actually. We have, I kind of want to form a tree, so I might have to kind of squish things together here for a second. So let me shrink this down. Fighters. Okay, so fighters are like the X-Wing and the TIE Fighter. The bombers are like the Y-Wing or any sort of like purposes for like land-based attacking versus air-to-air or space-to-space, I guess. Capital ships are big ships that are like the capital. I don't know if you guys know what capital is in general, but it's like the fleet. It's like the aircraft carriers, okay? If it was a normal non-Star Warsy thing, it's just an aircraft carrier essentially. And the frigate is kind of in between. It's a big slow ship meant to kind of defend the capital ships, I think. It can also be like a medical frigate or thing. So they're like bigger ships, but they're not like little tiny fighting ships like that, okay? So why are they different? Because maybe the capital ship has the ability to carry ships in it. So can carry other ships. The bomber has special weapons, but in addition to that, it might have like a special bombing tech. The frigates, they're bigger ships, so they maybe have, in addition to more capacity, they might have a type of frigate. So like type, if it's a medical frigate or if it's just like a battleship or something, I don't know. And then you have your fighters, which is what we've been doing so far. But in addition to being a regular ship, they might have the that's something. This probably has hyperspeed. What do they call it? Hyperspeed engine? What is it called in Star Wars? Like they can go fast. They can go really fast. It's they have a hyperdrive. Okay. Whereas maybe the fighters don't have that, but the bombers could have that. So actually, that's a good point. We could actually group these more, and as you can see, things are growing. We can actually group and say that everything but the fighters and the bombers have hyperdrive engines. And yes, I know some ships have hyperdrives in Star Wars with that are fighters, but technically I think the Falcon is a frigate. So we can actually put this hierarchy and say that there's two kinds of ships. Have hyperdrive, no hyperdrive. And then from there, we can group and say the capital ships are here. And then we have the frigates here, like that. And then we got the fighters and bombers here and here. Okay? Like that. So now we got a little sort of hierarchy of the different types of ships, okay? And then even within this, we could actually have different kinds of fighters like light fighter and heavy fighter, things like that, or capital ships and so on. But we still got to put in our cosmetic thing. So for our cosmetic thing, we may only be using that for the bombers, or for the fighters. So we could go ahead and have a fighter cosmetic skin, but we could also have a bomber cosmetic skin as well, and so on. Okay. Although I'm actually realizing that this might be a better thing to do for composition. Okay. So because here's the thing, if we go back to our sort of relationship thing about inheritance versus composition, we can say that a bomber is a ship. Okay, that is a ship. A capital ship is also a ship. A fighter is also a ship. But, we can say that the hyperdrive class ship is a kind of ship, and then the no hyperdrive class is a ship as well. So we can say that the capital ship is a hyperdrive ship. Okay? And then the bomber is a no hyperdrive class ship. That's one way that we can order this, which is what we have now. Alternatively, we can say with the has system, okay? So with the has system, we can say that a capital ship has a hyperdrive or does not have a hyperdrive. Both will work. But if we decide to do it that way, then we could separate our hyperdrives into being its own little class called hyperdrive, which could work better. So then we can get rid of these guys and these and and bring them back up here. But then we can take our hyperdrive thingy and then shrink it down so that it fits, and then just put it inside of each of the classes that have hyperdrive. Like that, has a hyperdrive in it. And then this one has a hyperdrive in it. And then just not put anything on those. We could do that as well. In that scenario, we are not inheriting, we are adding it in. We are adding this class, which is unrelated, it's independent of the ship class, but we're adding it in. And when we have a class inside another class, and we're just adding it in like that, that would be a has-a relationship. And that will be an example of composition, okay? So there are many ways that you can organize your code to use inheritance and composition. The idea of doing either of these is not to make your code harder. It's actually to make it simpler, to make it easier to understand for other people, to make it easier to work with because you're dividing and conquering problems, and also easier to fix if you have a bug. Because if you have a bug that is shared between all the ships, you just gotta fix it here, and then you're good to go. If it's a ship that's only working in capital, it's only happening in capital ships, then you fix it there. But that way, the bug that you fixed over here is not something you're gonna have to fix again in all of these, because the fix will propagate to all the derived classes, okay? Finally, I think for the cosmetic skin, it makes sense also to put it as a composition thing, because it has, we can say a ship has a skin rather than a ship, is a skin per se, or a skin is a ship. So we're gonna just basically shrink that down as well and put it in. Okay, and furthermore, just because this is going to get even more complicated, we can actually have a ship, or actually we can have fighters and bombers too, but we're just going to say fighters for now, that reside inside the capital ship, right? So we can actually have fighter classes in here, like that. And you're like, so you can have a ship inside a ship, like shipception? Technically, yes, because they're on the same level. They're not above it, so that's not going to cause a problem. And even if they were on the same level, you could fix that if you were working with pointers. But we haven't gotten to pointers yet. So I hope that kind of helps as an example. The other example, the one that I used last time, I'll quickly go over it, is think about creating a class called animal. You have a farm, and your farm is made up of a couple of animals, okay? So animal can be your superclass. It doesn't make sense sometimes, by the way, and we'll talk about this when we get to virtuals. It doesn't make sometimes to even make an object of the superclass, because what is an animal? Is there any animals that are just animals? No. There's dogs, there's cats, there's chickens, there's pigs, but there's no animal that's just called like animal, right? However, from there you can derive and say, two-legged, four-legged, and then from there you have maybe like a chicken. I suppose in theory a human, but this is a farm, so hey, yeah, the owners, I guess. Then you have the dog, the cow, and the pig. Okay, so these are going to be your derived classes because they're all animals. So they're all is. Hey, so a cow is an animal, a dog is an animal, a chicken is an animal, a human is an animal, I suppose. There's a Muppet named Animal, and he's two-legged too. Yeah, that's true. That would confuse us. So yes, No Muppets allowed in this farm, in this animal farm, like the book. But yeah, okay. So okay, I'm sorry. I just had like flashbacks of quotes from that book. But anyways, so it's a good book, by the way. But yeah, so here you can see that it makes sense to have this sort of hierarchy. You know, there is, you know, a two-legged animal is an animal, a four-legged animal is an animal. But we can also have aggregation in here and say that a dog has perhaps a class called dog tag, or just tag, I guess, a little tag. A cow could also have a tag in it, you know, because they carry a little bell, I guess. I don't know. I don't know if they actually carry bells in real life, but I've seen it in movies. Like, the bell. What is that for? I don't know. But yeah, whereas maybe a chicken has the ability to fly, so maybe it has a fly function in it, and that's really the only difference between this and this. And the human has the ability to talk, to speak, you know, and this barks, and this moves, and this oinks. Okay, so all in all, hopefully either of these examples give you the idea that when you're developing classes, because you don't want to have to copy and paste code, you start with a base class that has all your shared attributes. And from there, you create derived classes that expand upon your initial idea of the class to add extra features. And you can do this in the chain like 4 layers in. Like, imagine you're making an animal kingdom tree, you know, like phylogeny tree. That goes pretty high. Like, I mean, I don't remember all the names for all the layers, but like, you know, there's like at the bottom is going to be your genus and then species or whatever they're called. So generis, I don't know, it starts with a G, but yeah. So you can make these trees, and again, the idea is not to make your life hard. It's because if all of these animals, you know, all the animals have a name. That's something that they all share. They all have a name. Okay? So that's something that you can declare in the superclass, that they have a name. And that way, you don't have to write a variable called name in every single class, right? We have an animal, it has a name. There's an animal, there's a name. We have names, right? If there's like, I guess you could say like if God was writing code, he would make a superclass called animals and have them both have like a name, I suppose, okay? So kingdom, phylum, class, order, family, genus, that's what I was thinking of, and species. So there you go, okay? So now let me actually show you the syntax of actually creating creating inheritance and composition. So let us begin. Go away. Okay, so the syntax for creating for inheriting in a class is you go ahead and you write the word class as before. You write the name of the identifier for the brand new class you're making. So let's say we're doing the animal example, because we'll do the ship example anyways. So let's say that we're making, so first let's make an animal class, I guess. Class animal, you know, you do like, when you're doing a normal class, you do class, identifier, and then your curly bracket, and then you have all your class members, and then curly bracket, and then semicolon, right? That's the syntax for a class. For inheritance, you're going to put class, you're going to put the identifier, a new identifier, brand new one. So this could be like dog, two-legged, whatever. Then you're going to put a colon, just one colon. That's like scope resolution operators, 2 colons. Here's just 1. It's kind of like when you were doing the initialization of your variables. We used a colon in your constructor. Right here. Remember that? It's kind of like that 1 colon there. And then you're going to put the identifier of parent class. Okay? I'm going to space this out to the line beneath it, okay? Because there's one more thing I want to add in between them. And then you put a curly bracket, and again you put your class members, which can be 2 things. New ones, but you can also do overload. You can also overload functions and replace older ones. So you might want to overwrite. So I guess actually, no, it's not overload. It's overwriting. Yeah, overwrite. You can actually technically you can overload them too. If you're overloading a function, it would be both. So yeah, technically both. Overwrite and overload. Base class variable functions. Functions, not variables. Okay. Again, you'll see an example of this. But really, what you're gonna do is, if you want to add anything else, like the skins or whatever we're adding, you can put it in there. But also, you can overwrite some functions. What kind of functions do we need to overwrite? Well, our print function is no longer effective because it doesn't print out the skin name. So we're going to have to rewrite the function essentially, which is really going to be copying and pasting plus a little extra. That's okay. We can actually call the parent function for print and then see a little bit after that. We'll do that. Yeah, we can do something like that. So those are the kind of things that you may want to overwrite. You might actually just add new functions too. Like we did with the show skin. So those are the kind of things that you want to do so that you're not forced to use every single thing from this parent class. The idea again is to save yourself from writing extra code and having to have code where you have to fix the same bug in multiple places. That's always an unfortunate thing to do. Okay, and then this will be the identifier parent class. This right here is just the name of the parent class. Okay, so it will be ship type in our case. And then here is just the new name. So, oh, that became a pink color. This is what I meant to do. This is a new name right here. Okay, but this, and then this one is a parent class. All right, although I can't actually leave it there because I'm going to write something there. So I'll get rid of that. Maybe I'll put it over here. One more thing you got to add in that's optional, but you will typically add it. You need to add in a public or a private right here. There's also protected, which I almost am ready to talk about, but not yet. Okay? You can put a public there, or technically you can put a private, but by default it's private. So what am I talking about? Okay, you guys know what public and private is in the context of like class variables. Okay? However, when you do inheritance, you have the option of converting your public variables into private variables. Why would you want to do that? Well, good question. I gotta think of an example now. You would want to do that if you have a situation where let's say you have a class that you're trying to extend upon, but there are things that are public there that in your new class you don't want people to mess with. I suppose that would be an example to make it private. Yeah, that could be. I mean, I know it's kind of a lame example, but I'm just saying it's possible to do it. However, what you might be thinking is, okay, maybe there's a better usage of making something private into public so that I can access private variables. No. That you're not allowed to do. I told you ways of hacking into private variables last time. Well, very briefly I showed you. I will show you in detail when we get to pointers. But no, that's not one of the things that you can do. You can make something less secure, but not... Sorry. You can make something more secure, but not less secure. So if you have a variable that's private in your parent class, such as we have our HP that's private, if you inherit into the derived class something that is private, it will remain private. If you inherit something that is public, then you have the option of keeping it public if you write the public keyword, like I did, or it will be converted into private automatically, or you can actually explicitly say private. However, what I said isn't 100% true. And the solution to that is why there's a third term called protected. Okay? So, what actually ends up happening is if you have a private variable and you try to inherit it, you know, when you do inheritance, the idea is that you can extend your class and access your class variables and everything. Because remember, a class function can access any of the variables inside the class, whether they're public or private. It can access them and have no problem, right? An inherited class has problems doing that. So let me give you an actual example of that. So let's say that we have a class A, and there is a public variable int x, and there's a private variable int y. Okay? So if I try to inherit from this class, I do class A colon B. Okay? If I do this like this, I am inheriting in a private manner per se. What that means is that all of the variables in class A are now considered private. Okay? So that means that if I try to access in a function here, void foo, I try to say cout x, that is going to print out the x right here. And it will. Oh, yeah. Yes, my bad. Apologies. Yes, it is backwards indeed. Oops. So if I try to access the x there, it will print it. Thank you for catching that. So here's the issue though. If I had an object in main of class A, so if I have a main here, and in that main I have AA, I suppose, I can go ahead and do this, a.x, you know, and cout it, assign it, whatever I want. However, if I do a B, and then try to do b.x, you know, gets 5, and this one gets 5 as well. This one's okay. This one's not okay. It'll tell me that it's private. And that's because when I inherited, I did change the default. I inherited privately. So while internally I have no problems, with public variables, it will change them to private. So I can alleviate that by putting public here. That will basically have, if I have a public variable here, I will inherit it. I will still be able to do this line of code, but in addition to that, this line of code will work just fine because it will treat it the same way. So I would say that 99% of the time when you do inheritance, you want to put in the keyword public there. However, the other 1% of the times is why I'm actually covering this in detail, so that you are aware of what's happening. Let's actually talk about why. Why is more of an interesting scenario here. Here's the thing with why. Suppose that I want to, you know, make another function, so I'm just going to copy and paste this. And I'm going to call this function bar. And bar is going to cout y. You would think it's this y. And you would be correct in thinking that that is that y. However, this line of code is going to give you an error. Actually, I believe you have the same situation where I think both compile if you put public afterwards. But yeah, do it that way actually. Yeah. So just like the syntax I have up here, where you put it right there. So yeah, thank you. So here's the thing. This will give you an error saying that y is private and you can't access it. Even though it's a class variable and you're supposed to be able to access it, it'll give you an error and say it's private. And so now you have a problem. The point of doing inheritance was to extend the functionality of the class. But you still want to access all the variables, right? Otherwise you're sort of hampered, you know, you're handicapped in your ability to, you're limited in the ability to access things if you can't handle private variables anymore, because then you're forced to handle those private variables in the superclass. So one solution is what you're saying. Yes, you can inherit a getter and setter function, but suppose that you wanted the variable to be internal. Thinking back to our example, we have our ID, and the ID is private. However, we have a getter, but we don't have a setter for it, because the only time the ID is modified is in the constructor. But suppose that you want it when you destroy a ship to decrease the ID because you can make that ID reusable, okay, or something like that. You still want to have access to the ID internally in the class. You don't want to make it public. You can use the getter and the setter, but that's going to make it public, and you're going to have problems because then a bad coder is going to go in and try to change it. So the whole purpose of a private was that we can control who can modify it outside of the class. But inside the class, we can do whatever we want. And so this is the dilemma that we have right now with inheritance. And this dilemma is going to be solved by introducing the third category of a variable between private and public. And those are called modifiers, I believe. I think that's what they're called, modifiers. Like public is a modifier and private is a modifier. The third category, the one that I might have mentioned if it slipped my tongue earlier, or yesterday or today, is protected. That's going to be our Superman, our superhero to come to the rescue. Protected is the third category of variables that you can create in classes or structs. How do they work? Okay. If all you're doing is a single class, you're not doing inheritance, you're doing just like what we have so far, and you call protected, you create a protected variable. So like, if I go in here, and instead of private here, I make these protected. I could keep them as private, but I'm saying if I switch them to protected, you won't notice a difference. Everything will be the same. Public variables, you can still you can access them anywhere you want, where you have access to the object. Private variables, you can only access inside the class. Protected variables, you can only access inside a class just like private variables. So essentially, at this tier, when you're just dealing with a single class and no inheritance, private and protected are going to be doing the exact same thing. For all intents and purposes, this code would do the exact same thing. Assuming that I haven't modified the code enough to break it, which I probably have. Let's see. Oh yeah, we added that random inheritance example in here. So let me just remove that from there. And then ship type 4 takeoff. Let me remove this one from here. And then put that there. Okay, so we got it to compile. So if I run it, it still runs the exact same way. But I am now using this protected thing instead of private. So for all intents and purposes, private and protected do the same thing when you just have a base class. Where you get the superhero effect of protected is when you do inheritance. When you do inheritance, if I have my class A here and my class B, if I switch this from private to protected, now when I go ahead and do the inheritance, and I also inherit publicly, the Y here in the inherited class will be treated as a private variable in the sense that you can still access it, unlike where you couldn't access it when it was private. So it will be accessible by the derived class, but outside the class, if I try to do b.y, this will give me an error, just like it would in A. Both will give me an error. So it'll be private for all intents and purposes in the outside of the class, but inside the class, unlike private, you will be able to access the variable by inside of your class functions. So the difference between private and protected is that for outside the class, they're both the same. They both are not allowed to be accessed outside the class. But inside the class, when you do when you have just the base class, again, they're the same. They cannot be accessed. But when you do the derive, when you derive the class and you have class B, you can access the variables as if they were your own, which is the same functionality that we had if it was in the parent class. So that's the solution to the problem that I introduced. So whenever you're doing object-oriented programming and you expect to create derived classes, the best thing to do is just to make it protected. That way, in your derived classes, you will have access to the variables if you need to, and only the class functions will have access, which is what you want to maintain, because that's the whole reason that we made it private in the first place. So that's why now it's protected. Okay. So do you need class before ship type tree? Where? In the other code here? I don't know. Maybe. Again, I was just kind of typing a bunch of stuff here. No, this is just a declaration. I'm just declaring an object of the global scope. It was just part of the example. Frankly, we're gonna just kind of get rid of that and redo it next time. Like I said, we're gonna do this right. This skin expansion pack, we're gonna do it right using inheritance. That's gonna be next class's sort of beginning code. So that's something to look forward to. But what is that skin? Emote. So, do you guys understand the difference between public, private, and protected? There's a little chart. I'm gonna try to find it. I think it's in the book or it's on the internet, one of the two. That kind of reminds you this. So let's see if I can find it. Okay, so it's not there. So let me try Googling public versus protected versus private C++. It might be on tutorial point. Can't find it. Maybe I have it on Canvas, but I could have sworn that. Let's try typing in protected. Can't find it, but if you look in the book, I think that in the book there's a little chart that's a reminder, so it might be useful for you, like, to remember. But basically, it's like I can kind of mimic it from memory. It's like we got public, protected, and private. And then it's basically the chart name is accessibility of the variable or function. Okay, and you have 3 categories. This is going to be outside of class, inside of class, inside of derived class. Okay, and then I'm going to use yes, Y for yes, and N for no. So public variables are accessible outside of the class, inside of the class, and inside of the derived classes. Private variables are not accessible outside of the class. They are accessible inside the base class per se. So I'll put the word base to clarify, but they're not accessible inside of the derived classes. Protected variables are not accessible outside the class, but they are accessible inside the base class, and they are accessible inside the derived class. So that's kind of what the chart is, except it's much nicer and prettier looking than mine. But that's kind of the one, because this is what you want to have available when you're coding or when you're taking the test, so you don't accidentally screw things up. Now let's see what the question is. So then we should really only use private in classes, or where if we absolutely do not want anything outside the class of the present class to access the function variables of the class. Then private for when we want, I'm assuming what you meant, and protected from when we want inter-class usage. Yes, yes. You kind of got it. So basically, if your class is happy and you really don't expect, so like for example, I know I've been using the ID as the example that we could actually switch to protected, but I think the ID is something that does not need to be messed with in any derived classes, because the derived classes can add functionality, modify functionality, but the ID is unique to each entity that we're making, each ship. So that's one that I think is actually a good idea to leave private to avoid any sort of accidents from happening, right? So that would be something that I would actually support as leaving as private. But the majority of your variables, you probably want to make protected, because you might want to modify them in a derived class. Now you can always go back and change that. That's okay. So I would say that most of the time you want to use public and protected, just to sort of be safe. Because I mean, you can always go back and change it later if you really want to. Protected can be accessed by the inherit classes, but not in main, for example. Yeah, protected is going to be sort of like private. In fact, protected and private, as you can see in this chart, are almost the same thing. They're not accessible outside the class, and they are accessible inside the base class. But the difference between protected and private is going to come in the third column there, which is the derived classes. Private cannot be accessed in the derived class, but protected can. So if we, in our example here, when we have a function in the derived class that's accessing a variable from the parent class, this variable is protected, so we're okay to access it. If it was private, then we would not be okay. So I guess I'll leave it. I'll make a variable z. So this z, this is the red one there. We would not be able to access from class B at all. We can't access it. It exists in our class. Like it is actually present in our object B. It is actually still there. We just can't access it. We can hack into it, whatever, because it's there, but we can't get into it. But it is definitely present in the class. Okay. As to for y and x are okay to be accessible from there. And if you have a global scope, then the only one that's accessible in that global scope is going to be the x. Okay. So if you want, over the evening tonight or tomorrow or whenever, try actually coding this little example here with the class A, and then class B. And then play around with it. Try to just change X, Y, and Z in this class A. Try changing it in class B, and try changing it in main. And play around so that you can really understand this chart. And, more, because yes, anybody can memorize charts, but you got to understand it so that you can really take advantage of it. So, we'll revisit this because I haven't coded some examples. So we will code again. We will modify the ship example, or we'll do something brand new. I don't know. We don't have to follow that example. So if you guys want to just start with something completely different, we can. But otherwise we'll add the DLC. We'll add the skin DLC. So yeah, that's I suppose part 1 of 2 of inheritance and composition, since we're not truly done talking about them. We shall finish talking about them on Monday, and then let me see the calendar here. From there, we switch to pointers. So yeah, I think we'll spend the full day on Monday to continue talking about this, because we just completely changed gears after that. So we gotta I want to make sure that you guys not just kind of, we still got to talk about the concept of encapsulation and polymorphism, and there's one more that I will remember. I just saw it like 5 minutes ago when I was looking for the chart. So yeah, any questions? Now's your chance. We've got about 5 minutes. In the meantime, and I'm gonna try and find that chart. Where is that chart? No class tomorrow. Yes, no class tomorrow. This class only runs from Monday to Thursday. And by the way, I actually, I'm glad you said that. I originally announced in the first day that the test was going to be on Friday, August 14th. But that is not the case because we don't have class on Fridays. So I can't make you come and take the test that day. So that your test is actually one day before, August 13th, from 5 to 6:55, okay? So I suppose in that scenario, both your midterm and final are on a Thursday, okay? Did you find the chart? Is that the chart? Let's see. That is a chart. That is a chart that looks almost like the one, but it's not the one that I've seen before. I guess the one, but essentially that's kind of the same thing. Within the same class and derived outside the class. It's just, this one is flipped from mine because mine I put this column at the beginning, but it's otherwise the same information. So that's why this one actually looks nicer because it kind of flows with the yes and no's. So yeah. So since we can't use any pre-made swap function in sorting in assignment 1, can we also follow the steps of swap algorithm? It's a swap function. You should be able to code a swap function on your own. I mean, here, let's code one right now. We got 2 variables that you have to pass by reference because otherwise you can't swap. So we need to make a temporary variable called temp, and then we need to copy one of the variables into it. So let's take A. At that point, we have A, and then we overwrite it with B. We are going to overwrite the one that we just copied off so that we don't lose that data. If we did B equals A, we would lose the value of B. After we do that, then we can go ahead and update B to have the original value of A, which is that. Bam! Swap function is done. You don't need an algorithm for that. So, Yes. I'm not trying to make fun or anything, but I'm just saying, you know, you gotta refresh your 135 because I'm pretty sure that they cover that. But yes, cool. Now we have a swap function which we can use in our program. I guess if you want to swap from weapon 1 to weapon 2, I don't know. But we have a functionality of swap, right? We paid money for this swap function in our ship game, so we better find some usage for it because it's staying there. So yes, maybe swap the pilot with the co-pilot or something. Do you know when you will have yesterday and today's lecture uploaded on YouTube? Yesterday's lecture is already on YouTube. I always upload them at the end of class, and they always take a few hours. Yesterday's one was, I think, went live at like 11:45 p.m. Expect today's to go around the same time because of I actually only take about half an hour. My internet has been happy these days. It takes about half an hour to upload. But then it takes about 4 hours for YouTube to, maybe 3 hours for YouTube to actually process the video and publish it. So yesterday's lecture I saw it was up around 11:45. So yes, just go to on my YouTube channel, add the playlist for this class, and then set notifications for that, and you will get a notification whenever I add a video to the playlist. You can also set notifications for my full channel, but then you'll get notifications from the 219 lectures. So you might be like confused. So yeah, I think you can do that. I think you can set notifications for a playlist. So just go ahead and do that, and then you'll be good to go. Because I don't always post them on Discord. I posted the first one and the second one, I think, because you know, just to kind of familiarize you with my YouTube. But yeah, just set up that. You know, just assume that will be always the case that I will upload them, unless I'm dead. I'm a little stumped on how to do the string find substitution for the string. Well, how to find? Well, you gotta think about it like arrays. The two strings that you're doing are arrays. You have a tweet that you're looking at, and then you have the string that you're looking at, that is the phrase that you're trying to match. So you're looking for the phrase inside of this. I don't like using hands when I can use pictures. So you've got a string that says I like cookies, okay? And say you're looking for the word cook. How do you pronounce that? I can't pronounce it. Okay? What you want to do is you want to put this at the beginning with this one, like this match, and then slide this down and keep comparing the first character until you find the C. At this point, you find the C right there. So then you want to look at these ones, this ones, and then this ones. And if they all match, then you're good to go. How to actually achieve this in code is you want to have a for loop on the outside that is going to run through all of the tweet text, all the characters there, because it's an array. So index 1, 0, 1, 2, 3, and so on. Then inside of that, you want to have another for loop that runs through the phrase that you're looking through. In most scenarios, you're going to be comparing, let's say that this is called R and this is called PH for phrase. You're going to be comparing the I from here and the J, because these are going to be like for loops, to see if they're equal. And most of the time, they're not going to be. It's only going to be actually in this scenario where they're going to be equal. So if that's the case, then you can just go ahead and break out of the inner loop because it failed. However, if they match, then you can just keep going in that inner loop. And then, how do you know whether or not you succeeded? Well, if you check through all of these and you fall out of the loop, so out here, then you can go ahead and have a Boolean variable called success, which you can set to true. Or you can, and then at that point you can even break out of the loop. However, if you do break out here, then you want to, before you break here, set your success to failure. And that way you can, otherwise you'll find false positives. So yeah, that's sort of the quick and dirty way of doing that. So, yep, you're not the only one. Also, the 135 students did do this assignment before in summer 2. So you might find some luck scrolling up to the Discord chat for like last week, and there might be discussion on this. I seem to recall people having questions about this in 135, and then I showed them code, but I can't find that code. Yeah, there's also special cases where yes, you want to make sure you don't go out of bounds. In the case of like you're looking for something at the end of the phrase. You know, my dog just knows that like the time is over because like she just came and she's licking my hand like constantly. She just knows it's like it's playtime or something. Like she has some sort of hidden clock or something. Hello, Padme. They have like a very advanced clock, like literally exactly at 7 she came up and was like, yo, the end has arrived. When the user inputs a string, there should be a null character at the end of that string, right? Yeah, but you don't have to worry about comparing that when you're doing the string matching. You shouldn't worry about that. And now she's back there bullying me to actually finish the lecture. So yeah, have a good weekend, guys. No class tomorrow, so I won't be here. So I'll be on Discord, but yes, until Monday, I shall see you guys. Make sure you get your assignments 1 and 2 done. I will post assignment 3 at some point, but that will not be due until next weekend. So it will just be there so you can start it on it. Because it'll have to do with inheritance and we got to finish it. So yes, thank you all for coming. Cool. Then I shall see you guys next Monday. Au revoir.